Have you ever stopped to think why a lemon is so sour, but soap tastes so, well, so bitter? It turns out it's not just about taste. It's about a hidden chemical world all around us, and even inside of us. So let's dive right in.
Yeah, it all really boils down to this one question. That sharp, zesty tang you get from a lemon and that awful taste you get if you accidentally get soap in your mouth, those aren't just random flavors. They're actually clues to two very different and very powerful chemical personalities.
And these personalities, you can think of them as belonging to two rival teams, Team Acid and Team Base. And let me tell you, they are complete opposites. Their unique traits define so much of the world we see, touch, and taste every single day.
Okay, so the core difference is all in the chemistry. Acids are what we call H+ ion donors. They like to give away a hydrogen ion. Bases, on the other hand, are the total opposite. They'll either take that hydrogen ion or give away their own hydroxide, or OH- ion. And that one tiny difference is the reason for everything else. It's why acids taste sour, and bases taste bitter and feel all slippery just like soap. It even explains why they have opposite effects on litmus paper. Acids turn it red, while bases turn it blue.
And you run into acids all the time, probably without even realizing it. That sharp bite in vinegar, that's acetic acid. The super sour power of a lemon, that comes from citric acid. The tang in your yogurt, lactic acid. And get this, even the sting from an ant is just a tiny injection of methanoic acid. They're everywhere. So if acids and bases are often just invisible liquids, how do we tell them apart? I mean, without tasting them, which, seriously, you should never do. Well, scientists have these little chemical spies that change color to reveal the secret identity of whatever they're in.
And I love this way of putting it. These chemical spies are called indicators. And just like a friend who might blush, these chemicals literally change their color to signal, hey, there's an acid here, or watch out, we've got a base.
And what's cool is that there are so many different kinds. You've got the classic litmus paper, right? Red and acid, blue and base. But check this out. Turmeric, yeah, the spice in your kitchen, stays yellow in acid but turns this deep red in a base. But my absolute favorite is phenolphthalein. It's completely colorless in acid, but the second it touches a base, bam, it turns this incredible, vibrant pink.
Okay, so now we know about the two teams, and we know how to identify them. But what happens when these two total opposites finally meet? Well, it's time for the chemical showdown.
When an acid and a base get together, they don't just hang out, they react in a process that's perfectly named neutralization. It's like a perfect cancellation. All the acidic properties get wiped out by the base, and all the basic properties get wiped out by the acid. Let's break that down. So, imagine you take a strong acid, like hydrochloric acid, and you mix it with a strong base, like sodium hydroxide. They react, and their special powers just vanish. And what are you left with? You won't believe it. Two totally neutral things. Sodium chloride, which is just regular table salt, and plain old water. All that chemical power just turns into something you'd find in any kitchen.
Now you might be thinking this is just something that happens in a science lab, right? Wrong. This exact reaction happens in your home and even in your body all the time. This is where the chemistry gets really personal.
I think pretty much everyone knows that awful burning feeling of heartburn. Well, that feeling is caused by way too much hydrochloric acid sloshing around in your stomach. So, how do you solve an acid problem?
You use a base. That's all an antacid tablet is. It's just a mild, safe-to-eat base. When you take one, it goes down into your stomach and performs that exact neutralization reaction, calming down all that extra acid and making you feel better. It's chemistry as medicine. All right, here's another one for you. That sharp, burning pain you get from a bee sting, it's not just from the little stinger itself. So what's actually causing all that irritation?
The sting actually injects an acidic venom right into your skin. So, what's the classic home remedy? You make a little paste with baking soda and water. Why? Well, baking soda is a base. When you apply it to the sting, it helps neutralize that acid, which soothes the pain. It's the same exact principle, just on your skin instead of in your stomach.
Okay, now let's zoom way out. This simple reaction isn't just for indigestion and bee stings. It's actually the foundation of a massive industrial process that creates some of the most important chemicals we use in our modern world.
And it all starts with something you'd never expect: salt water. That's it. It's called a brine solution, and it's just regular old salt dissolved in water. It's the super humble beginning for a huge industrial transformation.
This whole thing is called the chlor-alkali process. The name itself gives you a clue. Chlor for chlorine, and alkali, which is just another word for a base. The entire goal is to take that simple salt water, zap it with electricity, and split it into some chemical superstars.
So, how does this industrial magic actually work? It's simpler than you think. You start with the brine solution. Then, you pass a powerful electric current through it. And that jolt of energy is enough to break everything apart and rearrange it into 3 brand new and incredibly valuable chemicals.
And what do we end up with? First, there's chlorine gas. That's the workhorse that disinfects our drinking water and our swimming pools. Then you get sodium hydroxide, a super powerful base that's essential for making everything from soap and paper to clothes. And finally, you get hydrogen gas, which is used as a clean fuel and to make fertilizers that help feed the world. All of that from just salt and water.
So, you see, from the sour taste of a lemon all the way to the huge industrial processes that clean our water, it all comes back to that fundamental dance between acids and bases. Chemistry really isn't just in a lab. It's in your kitchen, your medicine cabinet, and basically every part of your life. The real question is, where else will you see this chemical showdown playing out today?